Hi, my name is Dimitri, and in this screencast I want to introduce you to CLion, which is a brand new C++ development IDE from JetBrains. So let's take a look at what happens when you run CLion for the first time. So the first thing it asks you is whether you have any previous settings to import. Then you get to pick between the light and dark UI themes. I'm going to go with the light theme here. Next up, you have to configure the build environment, and since I'm on Windows, I have an option of using either MinGW or Cygwin. CLion also checks the environment settings, making sure that I do have all the features necessary to build applications. Next up, we can select the plugins which are loaded by default. These include plugins for version control, also support for web development, and a few other tools as well. And finally, CLion is offering us the options to download a few featured plugins that we might need later on. Now we can start actually using CLion. CLion uses the CMake build system to organize files into projects. So when you fire up CLion, you have an option of making a new project, opening an existing one from a CMake lists file that you already have, or checking something out from version control. Let's make a new project, and I'm going to call this one Hello CLion. So here we are in CLion. On the left, you can see an arrangement of files that make up the project, and on the right, you can see the actual editors. Now this project has two files. It has main.cpp and it also has a CMake lists file. This is a project file. It essentially defines all the files which make up the project and also has instructions for actually building the program. Now let us suppose that I want to add another file to this project. I can do it in two ways. I can right-click the folder here, go into New and then choose File, or I can invoke a keyboard shortcut. Here I choose File and I give the file a name. Let's say test.h. If you look at the file here, you will see that it's grayed out. The reason for this is that the file is not included in the project. So we have to go back into CMake lists and add the file manually. Now that we've done so, CLion is telling us that the CMake project needs to be reloaded. We can reload it using this link, or we can enable automatic reloading, which will reload the project anytime that the CMake list file is changed. Now let's take a look at renaming the file. I can invoke a rename refactoring, and then I can provide the new name, for example, shape.h. After the refactoring is done, the file has been renamed both in CMake lists as well as the file name itself. At this point, I'd like to point out that the shortcuts that you see popping up down below relate to the default key mapping of CLion. You can configure an alternative key mapping that would support the shortcuts of NetBeans, Eclipse, or Visual Studio. With the cursor positioned over shape.h, I can use a navigation shortcut to jump right into the shape file. Notice as I type the pragma here, I get code completion for all the elements. Now let's make a class called shape, and notice as I open the curly brace, I get a closing curly brace and semicolon, and when I press return, I get the appropriate line breaks inserted. So this class will have a single function. It's going to be a virtual function for calculating the area of a shape. Alright, now I want a particular shape, like let's say a rectangle. So what I can do is I can make a class called rectangle.h and a file called rectangle.cpp. If I want to include the headers in the CPP file, all I have to do is start typing include, and then I get code completion for the actual files which are available. So in this case, I want shape, and I also want to have rectangle. I can now use a simple shortcut to get back to the header file. So let's also add a pragma here. And now I'm going to make a class called rectangle, and it's going to inherit from shape. Now I want my rectangle to have width and height, so let's have those. Now I want a constructor. What I can do is I can bring up the generate menu, choose constructor, choose the fields that I want to initialize, and press OK. So CLion has made my constructor automatically, and I can get getters and setters for the fields as well. Once again, select all the fields, press OK, and here are my getters and setters. Now we can finally implement that pure virtual function from the parent class. So once again, I bring up the generate menu, and this time I choose implement methods. I choose the area method. So notice what happens here. Inside the header, I get the function declaration, and I can click the link here to navigate to the actual definition. And here, I simply want to return width times height. Notice I get code completion here as well. So now that I'm done, I can go into main CPP and actually use the class. So now I can start using the rectangle. Let's make an instance of it, and I'm going to use an initializer list to initialize it. And then we can output its area. So I'll put in cout, then the rectangle area. Notice I can simply press return here, and then the end line. To run the application, we simply go into run and choose run hello CLion, and here is the result. So 3 times 4 equals 12, that's what we get right in the output. We don't have to pop up a separate console window. And CLion also supports refactorings. For example, we can take the literal 3 here and introduce a variable. We can even declare it as a constant if we want to. And we can take the 4 and introduce a constant in the global scope, like so. So once again, picking whether we want it static or not. And we get the constants here and here. Now CLion continuously analyzes the code that you write. So let's write something invalid. Let's suppose I want to get the perimeter of the rectangle, so I say int p equals r.perimeter. Unfortunately, the perimeter function does not exist, so CLion flags it as an error by highlighting the function in red and showing it on the marker bar on the right as well. But what we can do is we can apply a quick fix. So with the cursor over the error, I can press Alt-Enter and choose to create the new function parameter. And if I do, CLion is asking me what return type I want and whether I want to add any arguments to this function. And after I press return, 2 things happen. So first of all, we get the declaration inside the rectangle header, and in the CPP file we get a stub which we need to fill in. So here, predictably, I would return 2 times width plus height. So this has been a small demonstration of some of CLion's features, and to find out more, go to jetbrains.com/CLion.